In this video, we're going to take a look at some reaction stoichiometry problems for grade 11 chemistry. If you have the worksheet in front of you, this is reaction stoichiometry worksheet number 1. Otherwise, you can just look here on the video, pause the question as needed, and try this yourself before you hear the explanation would be the best way to use this. So we're going to look at number 7 and number 8 on this page. So number 7, sulfuric acid can be neutralized by the addition of calcium hydroxide. So we look down below at the equation and we see sulfuric acid, H2SO4, is reacting with calcium hydroxide. One of the products is solid calcium sulfate here, and the other product is water. And we're warned this was an unbalanced chemical equation. So stop, and we want to classify and balance the equation. So to classify it, we notice that this acid has hydrogens and sulfates together, and here we have calciums and hydroxides together. That's a positive and negative, positives and negatives. This looks to be the formulation of a double replacement reaction. So they're going to trade partners in a double replacement reaction. And we should find the hydrogens grab hold of the hydroxides, and that will create water. Even though we write H2O, we remember that water is really HOH. So the hydrogen and the OH make water. And then we have calciums and sulfates, which form the calcium sulfate salt. So to balance this, we've got 2 hydrogens here and 2 hydroxides here. Each hydrogen and hydroxide will create a water. So if I've got 2 of them, I'm going to make 2 waters. And looking at that, that appears to be balanced now. We have 1 calcium, 1 calcium, 1 sulfate, 1 sulfate. That's good to go. Part B, what mass of the calcium sulfate would be produced if 0.20 moles of sulfuric acid were neutralized? So go ahead and pause the video and see if you can set up some unit multipliers to solve that. So we have 0.20 moles of the sulfuric acid, H2SO4. And we're wondering what mass of calcium sulfate can we make. So because I already know the moles of the sulfuric acid, I'm going to use the reaction stoichiometry, the ratio right here. 1 mole of sulfuric acid will make 1 mole of calcium sulfate. So I can switch moles of the sulfuric acid into moles of calcium sulfate. And once I have the moles of calcium sulfate, then we can use its molar mass to convert the moles of calcium sulfate into grams of calcium sulfate. Okay, so the first unit multiplier, moles of one substance, moles of another substance, the numbers for this come from the coefficients in your balanced equation. So in this example, 1 mole of calcium sulfate will come from 1 mole of sulfuric acid. The second multiplier, moles and grams, or grams and moles, that's a molar mass. So in this case, the molar mass of calcium sulfate, we look on a periodic table, we look up calcium, sulfur, and oxygen, and we have 4 O's, 1 sulfur, 1 calcium. We add that up, we find that 1 mole of calcium sulfate weighs 136.14 grams. And now finally I'm going to grab a calculator and evaluate this. I'll take the 0.20 and I'll multiply by 136.14. When you're using unit multipliers, the ones are usually just ignored because multiplying or dividing by 1 doesn't do anything to your answer. So these ones and this one down here, we just ignore them. So 0.2, and the 136.14 is in the numerator of the unit multiplier. When it's on the top like that, you multiply by it. If it were on the bottom, we would be dividing by it. And finally, we look at the number of digits in our numbers. 0.20 has 2 significant digits, while 136.14 has 5 significant digits. So when you're multiplying and dividing, we keep the smaller number of digits. So in this case, we're going to keep only 2 digits in our answer. So your calculator will tell you an answer like 26 point something. I'm going to say the answer is 27 with 2 digits. Grams of calcium sulfate. Part C, how many moles of calcium hydroxide to neutralize 2.00 grams of the sulfuric acid? So we have 2.00 grams of sulfuric acid. How many moles of calcium hydroxide would you need to react with that? Pause the video and see if you can set up your answer. So the first thing I'm going to do is convert the grams of sulfuric acid to moles of sulfuric acid. That way we can use the balanced equation's mole ratios. And then the moles of sulfuric acid, we can get rid of it. And we're interested in how many moles of calcium hydroxide. So the moles of calcium hydroxide from the balanced equation, CaOH2. And now we need the numbers from the balanced equation, moles and moles. 1 mole of the acid will neutralize 1 mole of the calcium hydroxide. So 1-to-1 ratio again. And then over here, grams and moles, that's a molar mass. But this time the molar mass of sulfuric acid. So we look on a periodic table, 2 hydrogens, 1 sulfur, and 4 oxygens. We pick up a calculator and we find that 1 mole will weigh 98.08 grams. And so finally, with my calculator, I'm going to take 2 and divide it by 98.08, and then we can just ignore these 1s. The 2.00 has 3 digits, 98.08 has 4 digits, so I'm going to keep the smaller number of digits. My answer is 0.0204 moles of calcium hydroxide. All right, so now the next question is a little bit harder. It says, what mass of benzene, C6H6, needs to be burned to produce 20.0 liters of carbon dioxide gas, the gas being measured at STP? If you think you know what you're doing, pause the video and go ahead and try it. So the reason this question is harder is that there's no equation given, so we have to start by writing up a balanced chemical equation. We're burning benzene, which is C6H6. C6H6 reminds me that that's a hydrocarbon. A molecule made of just carbon and hydrogen is a hydrocarbon. And when you're burning it, you need to add oxygen. And now I realize this is a hydrocarbon combustion reaction. We've learned that the products of hydrocarbon combustion reactions are always the same things. You'll get carbon dioxide gas and you'll get water vapor when you burn hydrocarbons. So now we just need to balance this equation. When you're balancing the hydrocarbon combustion, it's a good thing to go in the order of the carbons and then the hydrogens and then the oxygens. So we have 6 carbons, we'll put a 6 in front of CO2. We have 6 hydrogens, we'll put a 3 in front of the water. And now, but for the oxygens, 6 times 2 is 12, plus 3, we have 15 O's over here. So what number times 2 would give me 15? Well, I can use a fraction and say 15 over 2. 15 over 2 times 2 is 15. Now, some people are totally fine using fractions like that, or even decimals. You could call that 7.5 moles of oxygen. But other people like to use the smallest whole number coefficients. So if you're going to use whole numbers, we need to get rid of this over 2. So to get rid of that little fraction divided by 2, we'll multiply all of the coefficients by 2. So then we'll have 2 moles of the benzene. Instead of 15 over 2, we'll just have 15 moles of oxygen. We'll have 12 moles of carbon dioxide, and we'll have 6 moles of water. Okay, so those are our smallest whole number coefficients. Now we can jump into the question. We want to produce 20.0 liters of carbon dioxide gas. And the question is, what mass of the benzene do we need? So first thing I'm going to do is take those liters of carbon dioxide and switch that to moles of carbon dioxide. And I can do this because we've memorized that if you are at STP, standard temperature and pressure, 1 mole of any gas will have a volume of 22.4 liters. In our next unit on gases, we'll learn about where that number came from. But for right now, that's just a fact that we've memorized, that if a gas is at standard temperature and pressure, 0 degrees Celsius and 1 atmosphere pressure, 1 mole of any gas would have a volume of 22.4 liters. So we can switch those liters into moles of CO2. We're trying to find the grams of benzene. So next we would take the moles of CO2, and using the equation, we can switch moles of CO2 to moles of benzene. And finally, we didn't want moles of benzene, we wanted the mass of benzene. So we can get rid of the moles of the benzene, and we can switch that to grams of benzene. So looking at these two multipliers, moles and moles would come from the balanced equation. 2 moles of benzene will produce 12 moles of carbon dioxide. And then this, grams in moles, is again a molar mass. 1 mole of C6H6, we look on a periodic table, 6 times carbon and 6 times hydrogen, you'll get 78.12 grams. And then finally, we'll do the arithmetic. 20.0 divided by 22.4 times 2 divided by 12 and times by 78.12. We'll keep, there's 3 digits here, there's 3 digits here, and there's 4 digits here. We ignore the coefficients when we're using significant digits. Those are pure numbers, they're not measurements. So the smallest number of digits was 3. So using a calculator, we'll round off the answer to have 3 significant digits, which will be 11.6 grams of the benzene need to be burned. Okay, so 11.6 grams of benzene will produce 20 liters of carbon dioxide. Okay, question number 9 on this worksheet. We have ammonia gas reacting with oxygen, and it's producing water and nitrogen monoxide gases. And the question asks what mass of nitrogen monoxide would be produced when 0.50 moles of ammonia reacts. So pause the video and see if you can set up your answer to that. So here we go, we've got 0.50 moles of the ammonia, NH3, and I want to know what mass of NO would be produced when this much ammonia reacts. So I'm going to convert my moles of ammonia using the balanced equation ratios into moles of NO. Okay? That's what stoichiometry is all about. Stoichiometry is about using the ratios from the balanced equation to make calculations or predictions. We didn't want to know the moles of NO, we wanted the mass of NO. So in one more multiplier, we'll switch the moles of NO into grams of NO. And now we're ready to do it. So moles and moles comes from the balanced equation. You get 4 moles of NO for every 4 moles of ammonia. Now mathematically, 4 divided by 4, this can be reduced to just 1 over 1 if you like, but I'm going to leave it as 4 over 4. Those were the coefficients in the equation. 1 mole of NO, we look up its molar mass on a periodic table, 1 nitrogen and 1 oxygen, has a mass of 30.01 grams. And now we're going to keep in our answer 2 significant digits. 0.50 has 2 digits in it. The molar mass has 4 digits. We keep the smaller number of digits. So 0.50 times 4 divided by 4, or if you realized, hey, that's really just going to cancel, you could ignore this. 0.5 times 30.01, and keeping just 2 digits, we get 15 grams of NO. Part B, if 10.00 liters of ammonia, measured at STP, was consumed, what mass of water vapor would be produced? Pause the video and see if you can do that. So we are using up, consuming 10.00 liters of the ammonia, NH3. And we're wondering what mass, how many grams of water vapor would be produced. So because the ammonia is a gas and because it's at STP, we can use that same unit multiplier we used in the previous question, and we can convert the liters of ammonia into moles of ammonia. Because when you're at STP, 1 mole of any gas has a volume of 22.4 liters. Now that we have moles of ammonia, we can use the balanced equation stoichiometry to switch moles of ammonia into moles of water vapor. And finally, we were asked the mass of water vapor. So we would switch the moles of water into grams of water using its molar mass. So from the balanced equation, 6 moles of water come from 4 moles of ammonia. Those are the coefficients in the balanced equation. And over here, 1 mole of water, the molar mass from the periodic table, is 18.02 grams. In my answer, I've got 4 digits here, 3 digits here, and 4 digits here. So multiplying and dividing, I'm going to keep the smallest number of digits, so we'll keep 3 digits in our answer. 10 divided by 22.4 times 6 divided by 4 and times 18.02. The answer will be 12.1 grams of water, rounded off to 3 significant digits. Okay? Part C, what volume of ammonia measured at STP would be needed to react with 2.5 moles of oxygen? So go ahead and pause the video if you want to try that yourself. So we have 2.5 moles of oxygen, and we're wondering what volume of ammonia would be needed to react with that. Looking up at the equation, the ammonia reacts with the oxygen. So I'm going to take the moles of oxygen, and using that balanced equation's ratios, the stoichiometry, I will convert that to moles of ammonia. The question was, what volume of ammonia measured at STP? The ammonia is a gas, so just like we saw a moment ago, we can switch moles of ammonia into liters of ammonia, because when you're at STP, standard temperature and pressure, 1 mole of any gas is 22.4 liters in volume. And from the balanced equation, 4 moles of ammonia react with 5 moles of oxygen. So 4 moles of ammonia for every 5 moles of oxygen. On my calculator, we have 2 digits and 3 digits. We're going to keep 2 digits in this answer. So 2.5 times 4 divided by 5 times 22.4 gives me 45 liters of ammonia gas at STP, standard temperature and pressure. All right, we'll do one last question together. Question number 11, if you've got the worksheet in front of you, says when a piece of copper metal is placed into a solution of silver nitrate, a reaction occurs, and one product is copper 2 nitrate, and we've got the formulas there. Classify the reaction and write a balanced equation in the space above, and it tells me using smallest whole number coefficients. So the 2 reactants would be copper metal reacting with silver nitrate. So copper is just the symbol Cu on the periodic table, and it reacts with silver nitrate, AgNO3. Now if you think about your reaction types, the silver and the nitrate, this guy's positive, nitrate is negative, and in class we describe that as they're dancing together. And this copper over here is by himself. He's going to go in and dance with somebody. Copper on the periodic table has charges of either +1 or +2. We're told it forms copper 2. So it's going to, because it's positive, it's going to grab hold of the negative nitrate. So we get copper 2 nitrate, CuNO3 2. Nitrates are -1, copper is 2 positive, so we need 2 of those nitrates to go with the copper. And that means the silver is going to be all by himself at the end. So in this reaction, copper metal is placed into silver nitrate. Silver metal would be precipitating out from that. To balance the equation, we have 2 nitrates here and only 1 nitrate here, so I'll put a 2 there to fix those nitrates. But that 2 gives me 2 silvers, so I'll put a 2 in front of silver as well. And now we have 1 copper on each side, 2 nitrates and 2 silvers. That's balanced. Okay, so it was a single replacement reaction, an element reacting with an ionic compound. And now the stoichiometry. What mass of copper metal would you need to react with 2.00 grams of silver nitrate? Pause the video and try that yourself if you can. So we have 2.00 grams of silver nitrate. And you're asking me how many grams, what mass of copper would be needed to react with this. So the first thing I'll do is I'll use the molar mass of silver nitrate to switch the grams to moles. Now that I have moles of silver nitrate, I can use the balanced equations ratios, the stoichiometry, to switch the moles of silver nitrate into moles of copper. If that's what we want to know, then we're done. But it actually asked me for the grams, the mass of copper. So with one more multiplier, switch your moles of copper to grams of copper, and you're done. Putting your numbers in, the molar mass of silver nitrate from a periodic table, 1 mole has a mass of 169.88 grams. That's silver plus nitrogen plus 3 oxygens. From the balanced equation, 1 mole of copper will react with 2 moles of silver nitrate. And finally, from the periodic table, the molar mass of copper, 1 mole is 63.55 grams. And now significant digits, 3 digits are here in the mass, 2.00. 5 digits are in this molar mass, and 4 digits are in this molar mass. So keeping the smallest number of digits, we'll keep 3 digits in the final answer. So on a calculator, you'll take 2, divide by 169.88, divide by 2, and then multiply by 63.55. So let's try that really quick. I don't have this one worked out. 2 divided by 169.88, divided by 2, I just made a mistake. I'll do that again. 2 and divided by 169.88, and I'm going to divide that by 2, and I'm going to multiply by 63.55. I'll keep 3 digits in my answer, 0.374 grams of copper. All right. Part C, how many moles of silver nitrate are needed to make 0.24 moles of copper nitrate? So we want to make 0.24 moles of the copper 2 nitrate. And we're asked how many moles of silver nitrate would we need for that. So I'm going to use 1 unit multiplier, and I'll convert the moles of copper nitrate into moles of silver nitrate. And we can do that because we have the balanced equation up at the top. 2 moles of silver nitrate would produce 1 mole of copper nitrate. So 0.24 times 2, we're going to have 0.48 moles of silver nitrate are needed to make 0.24 moles of copper nitrate. Okay, so those are several examples of basic reaction stoichiometry. None of them involved limiting reagents, and none of them involved percent yield. Those are things that we'll add on in another lesson about reaction stoichiometry. I hope that helps. Good luck with your studying.